This is the beginning of our lecture on section 2.5 in Math 107. It's the inequalities involving quadratic functions. The goals for this section, first off, we'll be solving quadratic inequalities, of course. We'll do them graphically, and then we'll also do them analytically, which people often call algebraically. One of the main applications with quadratic inequalities is finding domains of some functions that have quadratic expressions in them somewhere. And then we have at least one little application we can do that involves inequalities. The first example that we're going to do involves just solving inequalities graphically. And in fact, these two functions, the function f and the function g, are neither quadratic. Also, there's a third function here that is often overlooked. We also have, in the first two problems, we have the zero function. We have a function where all y values are zero. In other words, the graph of the zero function is the x-axis. We often don't write it as a separate function unto itself, but it is, and it's one of several dozen nuts and bolts functions that does a lot of work in math without having very much recognition. We're going to try to approximate the solutions to each of these three inequalities to the nearest 10th unit, and we want to write both interval and inequality notation for our solutions just to get some practice. So the first inequality, f of x is bigger than or equal to 0. Well, remember that when you're dealing with a function graphed in the Cartesian coordinate sense, f of x gives you your y's. The zero function is the x-axis. And the inequality is saying that you're above or on the x-axis. So this statement means for what values of x is the y above or on the x-axis with the graph f. That's the solid, straight, liney graph here. Well, this is the part of the graph of f that's above the x-axis. Right there is where you're on the x-axis. You have two x-intercepts. So all the x's that do this x, all those in between, will solve this inequality. If I pick any of these x's between here and here, and I find f of x, I will find a number which is bigger than or equal to 0. So this x will solve that inequality. So my solution will be all the numbers between approximately negative 4.5, and let's call that, that's approximately 2.7. So negative 4.5, 2.7. So negative 4.5 is less than or equal to x is less than or equal to 2.7. That would be the interval notation for that solution. To write the same thing down as an inequality, I got that exactly wrong, backwards. That is not the interval. That is the inequality. The interval would be here. Notice I'm using a square bracket for that. And a square bracket here. Since negative 4.5 is included in the solution, I need some way to denote that it's included in the solution set. So by using a square bracket, that means I'm included. This is a bit of review. Since I say less than or equal, the or equal part is how I say that the negative 4.5 is included. And ditto also for the less than or equal beside the 2.7. So this is a picture on the x-axis of the solution set, and I'll make those points bigger. That's the picture of the solution set, which is represented either with that interval or with that inequality. Now, I think it would be more fun to, let's go ahead with f of x less than 0. Well, this is saying y's are below the x-axis. And we're using the graph of f. Well, here is the part of the graph where y's are below the x-axis. The solution will be the x's that cause that to happen. So these x's cause the y's to be below the x-axis. Also these x's. If I pick this x, the y value is below the x-axis. I go down to get to the graph. So those x's cause the graph of f to be below the x-axis. Now, to solve this inequality, I need to be strictly below the x-axis. I don't have any provision to be on it. So I need to say somehow that I'm not on it. So we leave an open hole there, and I'm putting a big magenta hole around the dot that was with the other solution, and a big magenta hole around this one. So the magenta here is the solution to part B, and I'll need to get a big arrowhead on that. So that solves part B. I need to write down the solution now. So first as an inequality, so I can either be below the negative 4.5, so x is less than negative 4.5, or I could be above the 2.7. I have to write the word or here. This word or is required. Depending on how you change the conjunction between the two parts of the set, you actually change the nature of the solution. The proper conjunction here is or, because you could be here or you can be here. So, or x can be bigger than 2.7. That's the inequality. I could also do this as an interval. Translating x less than negative 4.5, that would be anything as far down as I wish to go on the negative x-axis. We represent that as negative infinity, up to 4.5. Since we're less, we use a parenthesis. That means we're excluding the endpoint. Now the or translates as the symbol union. And then we would be 2.7 up to as far as you could possibly go on the x-axis, which we represent with a positive infinity. So 2.7 to infinity exclusively. Okay, that solves part B. Now, with part C, we're asking where is the graph of f. So under or on the graph of G. Okay. Now, when we ask where, that means what x, or what possible values of x. So f of x, that's the solid straightish graph, is below the graph of G here. So here's the graph of G. Below means I can draw a line vertically from the top graph down to the bottom graph. That's what it means for one graph to be below the other. So the x's on the x-axis with these vertical lines are in the solution. I'm allowed to be on, that's an intersection point. So that would be a little bit shy of -4. That would be approximately, let's say -3.8. So for all x's below or equal to -3.8, we have the red graph is above the blue graph. Likewise over here, the red dash graph is below the blue solid graph because a vertical line from any point here goes down and actually touches the blue graph. Any point on the red graph, I can move downward to touch the blue graph. So that's what it means to be above. And it will be until about right there, which is about 4.1. Okay, so this inequality is satisfied by x's less than or equal to -3.8 or x's bigger than or equal to 4.1. If I write that as an inequality, -infinity to 3.8 inclusively, union 2.7 inclusively to infinity.